Yes. Now we are doing Pythagoras theorem series, theoretical problems for 10th class state and Cbse. This is not for Icse. Even though it is not there, they can listen this chapter. They can listen this series. It's quite interesting. So let me do this problem. Triangle ABC is an obtuse angle triangle. Obtuse angle at B. Triangle ABC is an obtuse angle at B. It's very clearly mentioned. Triangle ABC is an obtuse angle at B. You know what you mean by obtuse angle? Can anyone tell what you mean by obtuse angle? Obtuse angle, right? So obtuse angle means angle lying between 90 and 180, right? An angle lying between 90 and 180, more than 90, less than 180. That is obtuse angle triangle. Obtuse angle. Sorry. So triangle ABC is an obtuse angle. Is an obtuse triangle. Triangle ABC is an obtuse triangle. Obtuse angle at B. See the direction here. Obtuse angle at B. Right. So A, C. If AD is perpendicular to CB, AD is perpendicular to CB. Prove that AC square is equal to AB square plus BC square plus 2 times BC into BD. 2 times BC into BD. Product of the bases. Product of the parts of the bases. 2 times BC dot BD. I don't know, product of the parts of the bases. If the triangle is obtuse angle, then you have to prove that this is what we have to prove. AD is perpendicular to CB, already given. Right. Very simple question, easy to understand, nothing tough in this problem. Just apply Pythagoras theorem. So square on the hypotenuse. Problem question is clear. Triangle ABC is an obtuse angle triangle in which obtuse angle at B. Show that AC square is equal to AB square, something they give. AB square plus BC square is equal to 2 times, you can remember like this, twice the product of parts of the bases. Parts of the bases means BC times BC into BD. When the angle is obtuse, you have to remember this as a formula when we do more problems in the coming session. You have to write direct step, this one. So how to do this one? Simple. Consider triangle ADC. Apply Pythagoras theorem. Or no. Consider triangle ADC. Right? Here it is given that AD is perpendicular to BC. Right? So that's why this angle is 90. So obtuse angle, already I told, angle whose measure is greater than 90, less than 180 is obtuse angle triangle. Acute angle triangle. Acute angle means angle lying between 0 to 90. So don't go much deep into that. Just concentrate on this. Apply Pythagoras theorem. Consider triangle ADC. AC square is equal to what? Square on the hypotenuse is equal to sum of squares on the other two sides. AD square plus AD square. AC square is equal to AD square plus DC square. Right? DC square. This complete triangle you have to consider. Right? Now AC square is equal to AD square plus DC. DC length is what? DC length is nothing but this plus this one. DB plus BC. DC length is DB plus BC. DC length, how will you get this total length? DB plus BC. So now A plus B whole square. I told now in the beginning of the class, just you need to know A plus B whole square, A minus B whole square, and simple addition multiplication, that's it. in order to do this Pythagoras theoretical problem, state and Cbse. AD square plus A plus B whole square. A square plus B square plus 2 times BD into BC. Right? Now here you can see AC square 2 times BC into BD, already is there. So only thing is AB square plus BC square. We need to get that one. So here now in this triangle ADB, now in triangle ADB, AB square is equal to square on the hypotenuse is equal to sum of squares on the other two sides. AD square plus BD square. AD square plus BD square. So AD square plus BD square. AD square plus BD square, what you can write? AD square plus AB square. So AC square is equal to AD square plus BD square is nothing but AB square. AB square plus BC square plus 2 times BD into BC. And screw. So AB square plus BC square plus twice BC into BD. Very simple question. That's it. Problem finished. So just you have to remember, if the triangle is obtuse, so AC square is equal to AD square plus what? AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square, twice the product of the parts of the bases, twice the product of the parts of the bases, 2 times BC into BD. That's it. Next problem. Same in the case if in triangle ABC angle B is acute and AD is perpendicular to BC, prove that same question, same problem, but the angle is acute. In triangle ABC angle B is acute and AD is perpendicular to BC, prove that AC square is plus is equal to something they give. Let me draw the same figure and let me draw the diagram. AB, a triangle ABC in which angle B is acute. Earlier case what we have done, angle B is obtuse. Now angle B is acute. Acute means just now I told you angle whose measure is between 0 and 90. Angle B is acute and AD perpendicular to BC. AD perpendicular to BC, right? Prove that AC square is equal to, now this time we have to prove this one. AC square is equal to AB square plus BC square minus 2 times BC into BD. 2 times BC into BD. Two times BC into BD. This one. So once again, what is the question in this? Just like previous problem, triangle ABC is an acute angle triangle. Just remember like that, acute angle triangle in which angle B is acute and AD is perpendicular to BC. And AD is perpendicular to BC. Prove that this condition they are asking. AC square is equal to AB square plus BC square minus 2 times BC into BD. Right. Now you know very well AD is perpendicular to BC. AD is perpendicular to BC. By Pythagoras theorem, what you will get in this? AD is perpendicular to BC given by Pythagoras theorem. Consider triangle ABC. You have to consider this triangle. right? Consider triangle ADC. What can you say? Triangle ADC. AC square is equal to square on the hypotenuse is equal to sum of the squares on the other two sides. AD square plus CD square, right? So here AC square is equal to AD square plus CD. CD, how will get CD length? Suppose this total length is 10. This is 5. So something this is 3. So total length is 10. This length is 3. What is this length? 7. How will you get 10 minus 3 is nothing but 7. So that means BC minus BD. CD is nothing but BC minus BD whole square. Apply A minus B whole square. So AC square is equal to AD square plus BC square plus BD square minus 2 times BC into BD. 2 times BC into BD. So this is an acute angle, no angle B, like that. 2 times BC into BD. Next, again consider this triangle. Consider triangle ABD, right? Consider triangle ABD. What can you say about this triangle? It is an acute right angle triangle. Square on the hypotenuse. AB square on the hypotenuse is equal to sum of squares on the other two sides. BD square plus AD square. BD square plus AD square. So BD square plus AD square. Look at it here. Consider triangle ABD by Pythagoras theorem, right? So AC square is equal to AD square plus BD square. See here, AD square plus BD square. AD square is nothing but AB square plus BC square. Write this as it is, minus 2 times BC into BD. See here, AB square, AC square is AB square plus BC square minus 2 times BC into BD. How to remember this formula? That is the main problem here. Whenever they give triangle is acute, you should remember A square on the hypotenuse. This you should remember. Which is the square? This one. AC square is equal to AB square plus BC square minus AB square plus BC square minus this complete part, product of this complete base BC into BD, this part. Where you are starting, from here you are starting now, so BC into BD. This is the way you should remember the formula. It is nothing but directly formula. In the exam they may ask you like fill in the blanks. Triangle ABC is an acute angle triangle. Acute angle at B. AC square is equal to, you should write like this. This is nothing but fill in the blank. They will give as a blank, or in competitive exam they will give fill in the blank. Next, another question which is important one. State and prove Apollonius theorem. State and prove Apollonius theorem. Or you can say the sum of squares of two sides of a triangle is equal to, you can call this as state and prove Apollonius theorem. Apollonius theorem. Apollonius. Apollonius theorem. Or the question can be written, can be read as the sum of squares of two sides of a triangle is equal to twice the square on half the third side, twice the square on half the third side, twice is equal to twice the square on half the third side, is equal to twice the square on half of the third side, plus twice the square on the median. Twice the square on the median which bisects the third side. So are you understanding what I am saying? Just I will draw the diagram. The sum of squares of two sides of a triangle. sorry. A, B, D, C. What does it state? The sum of squares of two sides of a triangle is equal to, sum of squares of two sides of a triangle means AB square plus AC square, right? AB square plus AC square. The sum of squares of two sides of a triangle is equal to square on half the third side is equal to square is equal to twice the square on half the third side is equal to twice the square on half the third side. Twice the square on half the third side means this one BD plus twice the square on half the third side plus twice the square on the median. Twice median, AD is the median, plus twice the square on the median which bisects the third side, plus is equal to twice the square on the median, twice the square on the median which bisects the third side. Bisects the third side means this BD is equal to DC, right? Once again, the sum of squares of two sides of a triangle, sum of squares of two sides of a triangle is equal to twice the square on half the third side. Twice the square on half the third side. Half of this nothing, you can take BD or DC. Half the side on the third, half the third side plus twice the square on the median. Median means the line segment drawn from the vertex to the midpoint of the opposite side, that is called median. Twice the square of the median which bisects the third side, This is what we have to prove. Twice the square of the third side, half of third side, plus twice the square on the median which bisects the third side. So here, very simple, this is called Apollonius theorem. Now construction. Draw AN perpendicular to BC, right? Draw AN perpendicular to BC. Suppose if D overlaps with this, case 1. Suppose D coincides with N. So construction, draw AN perpendicular to BC. What I am saying is, suppose D coincides with N, and again already we know that you write down all the conditions. BD is equal to DC since AD is the median, right? Now I am saying that suppose if D coincides with N, so what is the meaning of that? So A, B, C, this D is coinciding with N. That means this becomes D. So both are 90, 90. Apply Pythagoras theorem. AB square, square on the hypotenuse, is equal to sum of squares on the other two sides now with this triangle. AB square plus BD square, right? Square on the hypotenuse is equal to sum of the squares on the other two sides. Suppose if D coincides with N, then consider triangle ABD. Now consider triangle ADC. Now square on the hypotenuse. Square on the hypotenuse is AC square is equal to AD square plus CD square. Right? Now what is given? AB square, add these two. AB square plus AC square is equal to AB square plus AD square plus BD square plus CD square, right? So AB square, what we have to prove? 2 times BD square. So here AD, here what is the meaning? 2 twice BD square. Here AB, BD is equal to what? BD is equal to CD, right? BD is equal to CD because AD is a median. So AB square plus AD square. So here AD square, AD square. This is AD square. Please remember AB square is equal to, consider triangle ABD. AB square is equal to AD square. This is AD square. AD square plus AD square is, here it is a mistake. Please make a note of it. AD square plus AD square is nothing but twice AD square plus BD square plus CD square. Right? 2 times AD square plus BD. BD and CD both are same, no? So BD plus CD is nothing but BD only, since AD is the median, or you can write BD is equal to DC. 2 times AD square plus BD is 2 BD square. So there ends the solution. Suppose if letter D coincides with N, this is the solution. Now again, this is case 1, hence already it is proved. Case 2, just I am erasing this one. This you can draw that diagram separately. Case 1 for this, case 1 figure. For this case 1, this is the figure, and we can consider triangle ADC. This part I shaded this. Be careful with this. 2 triangles, therefore add these 2, you will get this. Case 2. Now suppose D coincides with N, no? Forget about this one. Another case arises. What is that another case is? Suppose if angle D is ABD is obtuse. So if this is obtuse, obviously this will be acute, no? Because straight angle measures 180 degrees. Now, case 2, you can write case 2. Very important, children. In examination, they may ask this question. Case 2. What is case 2? Suppose, not suppose, let angle ADB obtuse. Angle ADB is obtuse. Therefore, if this is obtuse, then this will be obviously acute, because both 180 or anything. Therefore, angle ADC is acute. Right? Are you following what I am saying? Let this be obtuse. So, straight angle measures 180 degrees. The other part is acute, I am saying. Now, consider triangle ABD. Or you can say consider triangle ABD, right? Consider triangle ABD. So here this angle is obtuse. So just now I told, no? So you can write consider triangle not ABD, you can consider ANB. So consider triangle ADB. You can write consider triangle ADB and consider triangle ADB obtuse angled at angle BD, obtuse angled at D. Also angle ANB 90 degrees. So just now we have discussed, no, if the triangle is obtuse, what is the formula? Now consider this one. So D, B, A, and this is N. Just now we have done one problem. So what does that state? Just now we did one problem, no? If the angle is obtuse, how to remember this one? AB square is equal to AB square. Here it is this is a right angle. So AB square is equal to what? BD square plus AD square plus, just remember the first problem what I have done so far. Since this is obtuse angle, I am saying that from case 1 or from earlier theorem, AD square plus AD square is equal to AB square. AB square is equal to BD square plus AD square plus twice the product of base, twice the product of the parts of the base, plus 2 times BD dot DN. So are you following? Again I am saying this we are following from case 1 proof. Starting first problem which I have proved. AB square plus AB square is equal to, since this is the obtuse angle, so this becomes AB square is equal to BD square plus AD square plus twice the product of these two, right? From theorem you can write from theorem. Next, again this is acute angle. Consider triangle ADC. Consider triangle ADC, right? How we consider this one? Now consider triangle ADC. So this is apply Pythagoras theorem. This is apply Pythagoras theorem. AC square is equal to AD square plus CD square minus twice the product. I don't know, minus twice. From here we are starting. Minus 2 times DC into DN from theorem. You can write directly from theorem, right? Once again I will draw the diagram. ADC, and this is acute angle. So this is 90 degrees. Yeah. So square on the hypotenuse. AC square is equal to AD square plus DC square minus 2 times DC into DN. This is what just now problem number 2 just now we have put. Add these two. AB square plus AC square. AB square plus. Now before adding this, one more thing I would like to say. So here DN same. BD DC. What is BD is equal to? Both are same. No, BD is equal to DC. Since BD is equal to CD, right? BD is equal to CD. What I would like to do is, in place of BD, I want to write as CD. So AB square and left hand side AC square is equal to BD square. So remain as it is plus AD square plus this part twice here 2 times BD here. Okay, I will write directly. I will write in a lengthy step. So AB square plus AC square is equal to BD square plus AD square plus this one AD square plus CD square plus 2 times BD into DN minus 2 times DC into DN. So now BD square plus AD square, BD square plus, here BD square is there, BD square plus AD square plus AD square is nothing but twice AD square plus BD, since BD is equal to CD, no, BD is equal to CD. Since BD is equal to CD, right? So BD and CD is there. So twice 2 times BD square plus this and this will get cancelled because 2 BD and DC both are same since BD is equal to CD. So there ends the problem. Since BD is equal to, what you can write, AD is equal to CD. AD is equal to CD. Not AD, BD is equal to CD. Already we have written BD is equal to CD. So AB square plus AC square is equal to twice AD square plus twice BD square, because this BD, AD, 2 is AD square, BD and CD both are same. BD is equal to CD. Here we have written, these two will get cancelled. There ends the problem. So thank you students, I took a lot of time for this problem, and these 3 problems are very important. Please Please subscribe my channel, click on the blue color icon button and share with your friends. Don't forget to subscribe. Thank you students, have a nice day, bye.